industrial plant contains hundreds of mechanical and electrical components that need periodic maintenance. How well a plant runs is often determined by how well its maintenance is performed. And that is something that maintenance worker has a direct control over. And the better he performs his job, the better the plant runs. Now, as a maintenance worker, there are a number of things you can do to save yourself a lot of time and make your job easier and safer. Now, while there are specific maintenance procedures for most of the individual components in your plant, we're going to be discussing subjects that apply to all maintenance tasks. Now, these subjects involve the correct use of procedures, planning ahead for a maintenance job, safety tag procedures and safety during a maintenance task, and general rules for assembling and disassembling machines. We'll also discuss the importance of preventive maintenance system designed to keep equipment from needing repair work. Now, most maintenance tasks start with the discovery of a problem in the plant. Now, this problem may be reported by an operator, it may be discovered as a result of a machine breakdown or malfunction, or it may be discovered during a routine inspection. Now, no matter what the cause of the problem is or how it's discovered, maintenance will have to be performed to correct it. A preliminary investigation by a maintenance supervisor will determine whether the job should be done right then or later. But as soon as the specific course of action has been decided, the first step is to obtain a written work order or job request. Now, this form will vary in its complexity, in who has to sign it to authorize the work, and what information is required to be in it. But regardless of what it looks like, this form serves several purposes. First of all, it notifies the plant management of the situation. It tells them what's wrong, say, the cause of the problem, if it's known, what needs to be done, and how long it's going to take. It also authorizes the work to be done. Now, you may have to get this document before you can start anything, or it may be written up while you are making your initial job preparations. Either way, you'll need this document filled in and signed off before you can start work on the equipment. Now, the work request will say what has to be done, but it won't tell you how to do the job. Now, there are probably some maintenance tasks that you perform dozens of times, and you're familiar with them. But you shouldn't perform any maintenance task without having the manufacturer's written procedure with you on the job. If you do, you're taking a chance that sooner or later you're going to forget a step or you're going to wind up with a piece left over. Now, this won't happen if you use the procedure. See, the manufacturer's written procedure will tell you, step by step, exactly how to do a specific job. Some procedures will also contain a lot of additional information, such as tool lists and safety precautions. Almost every major piece of equipment in your plant came with a manufacturer's instruction or installation manual. And these manuals are probably kept in some convenient location. When you find the right manual, it's a good idea to take a quick look at the procedure right then and there. Now, this can save you time, all right? One way it can save time is that you may find that you need a special tool or part to do the job. As a matter of fact, this first review is a good time to make a list of all the tools you'll need, particularly any special tools that might take a while to get hold of, or the same for parts. See, you might have to order a part if it's not in the warehouse. Your warehouse staff will take care of this, but they deserve all the time you can give them to get something special. You may have to go through your supervisor for ordering, or it may be that a simple phone call will get this thing going. However your company handles this, if you get it going as soon as possible, you'll be saving yourself a lot of time farther down the road. Now, another way that this initial review can save you time is that sometimes you'll find that the procedure just isn't in the manual. All too often, you'll find that someone else has removed the procedure and has forgotten to replace it. So the sooner you find this out, the less delay there'll be in getting another copy of the procedure and completing the job on time. It's a very common problem, and it can easily be solved if your plant carries a duplicate set of manuals called a master set. Now, if there is a master set, you can have a copy of the procedure duplicated from it. Oh, and remember, before you take that manual with you, you make sure you sign it out so there is a record of who has it, all right? Now, at this point, let's review what we've covered, all right? First, you need some sort of paperwork that notifies management of the need for maintenance and authorizes the job to be done. Next, find and review the procedure for the job. Now, the initial review can save you a lot of time. Remember, always use the written procedure for a maintenance task and have it with you on the job. Okay, now let's stop the tape for a few minutes so that your instructor can explain your plant's work request system and where your manufacturer's manuals are kept. In the first segment of this tape, we discussed maintenance procedures and the importance of following these procedures whenever you perform a maintenance job. Now, hand in hand with any maintenance procedure must be an understanding of safety. So in this segment, we'll cover two topics: tag-out procedures and safety procedures. The tag-out procedure is an administrative process designed to protect people and equipment. It ensures that valves and switches are in the proper position to protect a worker or a piece of equipment. It also warns people not to operate these valves or switches. Now, these are danger tags. They're also called safety or hold tags. Now, all plants have them in some shape or form, and they're usually red for danger. Now, it's vital that you know what these tags mean and how to use them, because these tags can be lifesavers. Now, operating tagged equipment could mean seriously injuring someone or damaging a piece of gear. When a tag is placed on a component, it means that you can't start that piece of equipment, open that valve, or operate that breaker. Now, you may not be able to see any work going on in the area of the tag, but the tag you see may be for a job on the other side of the plant. Now, these tags are an essential part of your pre-task preparations. That's because you don't want any high pressure, high temperature, or corrosive fluids or gases entering a piece of equipment while it's being worked on. You also don't want anybody starting it while somebody's hands are in it. So, how do you tag out a piece of equipment? Well, first step is to find out just which components need to be tagged to ensure that you are completely isolating the equipment that you're going to be working on. Now, you'll need to tag out mechanical components such as valves and electrical components such as switches or breakers. Now, if the tag out list is a long one, you may need cooperation between a mechanic and an electrician to write it up. At some plants, the tag-outs may be performed by a senior operator, but however your plant does it, make sure the operators are involved. They're the people that know the system best, and the tag-out will be safer. Now, there are a number of sources that will provide the information for a safe tag-out. The plant's electrical prints will tell you how to tag out the machine electrically. For the mechanical tags, go to your plant's system prints and the manufacturer's manual. The drawings must be used to ensure an accurate tag-out. As a double check of your lineup, you can physically trace a mechanical system to see what has to be tagged out. When a complete list of what has to be tagged out has been drawn up, it has to be approved by an operations supervisor. This is one more check to ensure that it's right and it keeps operators informed of the status of their equipment. When the tag out has been approved, the tags will have to be hung and checked off one at a time. Now, this step will probably be done by the operators in charge of the equipment being tagged. Now, you may run into a situation in which Several maintenance groups are working on jobs involving the same equipment. Then a breaker or valve for that equipment may have more than one red tag attached to it. Now, if a component appears on your tag list, make sure you put a tag on it, regardless of how many other tags may be hanging from it. There must be a tag for every job, and you continue your tagging until the checklist is finished. Only after the completed checklist has been returned to the operations supervisor will you be able to start work on the pump. Now, you may get verbal permission or written permission or a copy of the checklist that allows you to start. But once that tag is hung, nobody operates that component.
I was working in one of the plants, and we had a problem with one of the fans in the plant. And they wanted to get the fan back in service. We had checked it externally and couldn't find anything wrong with it. So we felt that the problem was inside in the linkage. Now you have to stop and think, these fans are pretty good size. The blades on these things are around 24 inches long, maybe 12 inches wide, and there's 24 blades in there, so it's a pretty good sized fan. She turns up about 600 RPMs. So we had got everything ready so that we could go right inside and check it out and then get back out. If there was any problem, make the repairs. So my supervisor was there, and we were all waiting for the work permit. We come to find out, I found out at a later date, this fan had two circuits on it. It was an automatic circuit and a manual circuit. So evidently when they tagged it, they tagged the manual circuit and didn't tag the automatic circuit. At least this is what we think happened. So instead of standing there, my supervisor, he got the work permit, had it in his hand, so we popped the doors off of there. Getting ready to get inside it, when I hear something click, and I hear it start to whine. So I backed away from it. Man, this fan just took right off. 600 RPMs, man, she turns up a little speed. It scared me. It scared me good, because if I'd have been inside there, she'd have just chewed me right up. There wasn't no way in the world I could have stayed away from those blades. So I'm a little worried about things like that. I've seen it happen off and on in the plants. The guys just don't research, they're tired or what have you, late at night. They don't think. I always like to back check a permit. Ask the guy a few questions about the piece of equipment that you're going to work on. Make sure he's, put the tags in the proper places. This, you want a piece of equipment safe when you work on it. You don't want no problems with it. I tell you, if I went in that fan, she'd have just chewed me right on up. And I'm not ready for my wife to spend my insurance money yet. She's a good girl, but she don't need it that bad.
Remember three things. Isolate the equipment you're working on by tagging it out. Make sure your tag out is complete, and don't operate a component that has a tag on it. Now, when a job is complete, you'll need to get authorization from an operations supervisor to remove the tags. After receiving authorization, use the tag list to ensure that you remove all of your tags. If a component has more than one tag on it, remove only the tag on your tag list and do not alter the position of that component. The tag-out procedure is vital to personnel and plant safety. It must never be violated. It operates to protect you and your equipment. Now, we tag out components to make them safe to work on. We do a lot of things just for safety's sake. Safety is an area that directly concerns everybody, and part of your job preparation must include safety preparations. These preparations can include a lot of different things. Of course, you want to make sure a proper tag out is performed, and you always want to wear the regular safety equipment. You want to wear a hard hat and gloves and glasses. Now, if you're going to be performing electrical maintenance, there are some other very important precautions. Now, they include using rubber gloves, rubber matting, and insulated tools. Also, don't wear watches or rings or belt buckles. These are all metal and they conduct electricity. Wearing them during electrical maintenance could result in severe shocks or burns. Now, your text discusses electrical safety precautions in more detail. Rotating equipment requires its own safety precautions. Now, rotating equipment is anything that has a shaft that rotates at high speed, such as a drill press. Long, loose hair can be dangerous around rotating equipment, as can loose clothing or jewelry, so protect yourself. Tuck in your shirt tails. If you have long hair, keep it up under your hard hat. Be aware that a watch, a ring, or a chain can get caught in a piece of moving machinery. Now, some of the tools used during your maintenance will require some special precautions. For instance, you'll need eye protection anytime you beat on something, grind, weld, burn or cut, use an air hose, or use a lathe. The worker that doesn't use proper eye protection is risking permanent blindness. It's a good idea to keep face masks or goggles hanging near any grinding wheels or lathes. Solvents used for cleaning also require safety precautions. Now, the vast majority of these cleaning solvents can be extremely hazardous in several ways. First of all, some are volatile. I mean, they can ignite or explode if not properly used. Second, you can't breathe these vapors for long and not suffer ill effects. Almost all of them can make you very sick, and some of them can kill you. Now, a third hazard involving solvents is that some of them are very powerful, and they can be dangerous if they come in contact with your skin. So if you're working with strong solvents, wear a face mask to protect your eyes, wear an apron to protect your body, and gloves to protect your hands. If the fumes are particularly heavy, you'll also need some sort of respiratory equipment. Now, respiratory protection equipment is vital in hazardous atmospheres. Now, make sure that you wear the correct equipment in the correct manner. There are different types of respiratory equipment for different hazards. Make sure you find out exactly what you need and exactly how to wear it. The right equipment won't do you any good if it's not worn properly. Now, if you work in a nuclear plant, you'll also have additional problems to cope with. You may find yourself working in a contaminated area that requires the use of anti-contamination clothing, or anti-seize, sometimes with respiratory equipment. You may find yourself working in a high radiation area that requires special precautions. The Radiation Safety Organization in your plant will tell you what these precautions are. Just make sure you follow them to protect yourself. If you deal with heavy weights, make sure you use proper lifting techniques. Don't try to be Hercules. You'll wind up hurting your back. And back injuries are painful and they're long-lasting. Now, good rule is to use some sort of mechanical help for anything over 50 pounds. Now, this help can be anything from a trolley to full rigging. And if something does have to be rigged in or out of place, remember that rigging itself has a set of safety precautions. These precautions are discussed at length in the rigging programs. All right, now there's one more very important rule that must be observed whenever you're doing something hazardous. Whether it's working in the back of a live switchboard or entering a possibly hazardous atmosphere. Don't work by yourself. Follow the buddy system and have someone to back you up if you get in trouble. All right, now, before you finish your safety preparations, check the manufacturer's manual one more time. The procedure itself may recommend specific safety precautions. There are many areas of safety that you must pay attention to during your maintenance preparations and during the work itself. Some of these precautions are written down, and a lot of them you'll know through experience. Use the maintenance procedure to avoid making mistakes. Don't ignore safety procedures because you think you know them inside and out. That's making a mistake too, especially if you're working with or training somebody. The best approach to safety is to make it a habit. Okay, now let's turn off the tape for a few minutes so you can go over just how far your tag-out procedure works in your place and any special safety precautions that you might have at your plant. We've discussed 4 subjects so far that have to be dealt with when preparing for a maintenance task: the work request, the repair procedure, the tag-out procedure, and safety. Now the next 3 steps are troubleshooting the problem, preparing the work area, and obtaining all the right tools and parts to do the job. So first, let's discuss something that might save you more time and effort than any other aspect of job preparation, and that's troubleshooting. Now, troubleshooting is figuring out just what is wrong with the machine and why it happened. If you can pinpoint the real problem, you're halfway home. Now, if you don't know what caused the problem, you're going to have a hard time stopping it from happening again. So, well, where do you look? Well, start with the operator and the operator's logs. Take a look at the readings that have been taken on that machine. What you're looking for is a trend. That is, a slowly changing reading or indication of temperature, flow, or pressure. Now, if you don't find a trend over the last 24 hours, you look at previous logs. A trend is sometimes slow to develop. So you pick a couple of logs from a month ago and compare those readings with the most recent ones. Now, while you're looking at the logs, ask the operator if he can offer any information. Usually, the person who operates the machine has a good feel for any change in sound levels or temperatures. He can also tell you if there have been any changes in any support machinery that might have affected the performance of this particular machine. Now, when you've looked over the operating logs, the next place to go for information is to the machinery history records. Now, the machinery history records contain information on everything that's been done on a machine since its installation. Well-kept machinery history records are an invaluable tool in troubleshooting. You'll find what problems the machine has had in the past, what was done to fix the problem, and what caused the problem. You'll also find if and when scheduled maintenance was performed. Now, machinery history records also contain the results of the vibration analysis tests. Now, vibration analysis tests use instruments to measure a machine's vibration pattern when it's running. Now, these are taken when the machine is installed and periodically throughout the life of the machine. Now, any change in a machine's performance will be detected by these periodic tests. The vibration analysis test can probably tell you more about how a machine has been changing than any other source of information, and that includes changes completely undetectable to human touch and hearing. So careful investigation of vibration analysis records and the other information in machinery history may tell you exactly what's wrong with the machine you're working on. But machinery history records are only as valuable as the information that is put in them. So make sure that whatever maintenance you do on a piece of equipment is accurately recorded in the machinery history files. Now, our next source is a manufacturer's manual. Now, if you check out the table of contents, you may find that the manufacturer has provided you with another valuable aid to troubleshooting. See, most manufacturers keep records on their machines based on the input that they get from their customers. This information can often be found in a troubleshooting chapter in the manual, and it'll list symptoms, sometimes combinations of symptoms, probable causes, and solutions. If the symptoms exhibited by your machine match those in the manual, you may find the answer to your problem right there. All right, now, at this point, there's really only one other source for information. That's other people, including other maintenance personnel. your maintenance supervisor, and other operators. Now, if this problem has occurred before, then there may be someone around who can remember something to help you. Use this kind of information to guide you in the right direction. Right? Now, once you know what the problem is, what you are going to do about it, and how you're going to do it, you've almost completed your job preparations. The last two steps are to prepare the work area and to collect what you need to do the job. Now, these steps can save you time and frustration once you start the job. So, if at all possible, do your maintenance in the shop. Here, the lighting is good, tools are available, ventilation is usually better. You can put the machine on a bench or another area where you can easily get at all the parts that you need to work on. It's also easier to close off the area to traffic that might interfere with the job. But often the job has to be done where the equipment is installed, and sometimes that can be very awkward. When you're going to have to work in an area like this, you want to make sure that your job is going to be as easy and safe as possible. All right? Now, what can you do about a spot like this? Well, let's start with better lighting. Probably the best way to accomplish this is with drop lights. You may need several of them. Now, no matter how many you use, remember a few key points when dealing with drop lights. First, make sure the lights are electrically safe. They may have an inspection sticker on them stating the last time that they were safety checked. Now, if a sticker has expired or if there is none, ask one of the electricians to check the light for you. If a cord is frayed or a cage is missing, don't use that light until it has been fixed. Also check for fraying on your extension cords. And put the lights where they'll do the most good for you and for anybody else passing by. For example, if your work is going to involve removing flooring or handrails or shifting piping around, light up these areas so they can be seen easily. All right? Now, when you've taken care of the lighting, check out the ventilation in the area. An atmosphere that might seem a little stuffy at first could cause a major fatigue and health problem after a couple of hours on the job. When you're checking the ventilation, keep in mind what you're going to be doing. Are you going to be there a long time? Is it hot? See, heat can tire you out. Will you be doing any hot work, such as welding or cutting? Will you be using any solvents for cleaning? It may be that just shifting the local ventilation fans to fast speed will take care of you. It may be that you might need additional ventilation brought in. And in extreme cases, you may have to do the job wearing respiratory equipment. All right. Now, besides lighting and ventilation, think about what other safety precautions you're going to need. For example, anytime you weld or use an open flame, have a fire extinguisher nearby. You may need to rope off or barricade the area to keep people out of it. If you plan to move or lift any heavy objects, you'll need a chain haul before you start. Now, get all of these items before you start. If you wait until you need them, you'll have to interrupt your work to go and find what you need. All right. Now, one last preparation needed in your work area is cleanliness. Performing maintenance work in a dirty environment is inviting trouble. Grease or water on the floor or any other surface you're going to be working on can be slippery and can be dangerous. Also, if dirt or dust or rags or grease get into the machine that you're working on, they could cause additional problems. So clean up what you can before you start. All right, now once the area is set up and ready to go, all you need are the tools and parts to do the job. Now, based on your review of the procedure and your troubleshooting, you should already have a basic idea of what you're going to need. But what you want to do now is go through that procedure once again. This time, imagine yourself doing the job. Picture yourself in your mind removing that bolt. Now, what tool will you need to do that? Well, write it down. If you've done the job before, you may already know what you need, but even so, run through the procedure. Make sure you haven't forgotten anything. It's easier to do that than it is to have to interrupt the job. Now, when you have your list of tools, make sure you've included any cleaning solvents you'll need, rags, extension cords, and trays or buckets for parts. That's why it's important to review that procedure again and see it in your mind. Now, another advantage in making a list is that it can be used as a check-off sheet when you're at the tool crib. Now, that's much easier than trying to remember everything. When you have your tools, follow the same procedure for the parts that you're going to need. The parts you pick up are going to be based on what your troubleshooting says you'll need. So, the better your troubleshooting, the easier it'll be to determine what parts are needed. Don't base your parts requirements on what you find when you tear down the machine. The parts already installed may be the wrong parts, and that may be what caused the problem. So again, use the procedure to make your parts list. And on this list, don't forget that when you tear down almost any machine, you'll probably be replacing gaskets. So make sure you've got the right gasket material, all right, and bring along a couple of gasket punches, all right. And you'll also need to lubricate parts. So bring the right type of oil or grease, all right. So now you're ready to go. The tag out and troubleshooting are complete, safety precautions have been taken, and tools and parts are ready. The next step is to start the job. We'll discuss things to watch out for once you start a maintenance task in the next segment. But right now, take a few minutes to go over the material that we've just covered. The first three segments of this tape were directed at the various preparations you need to make before you start a maintenance task. Now we're going to get into the maintenance itself. It wouldn't be practical here to take a maintenance task like a pump overhaul and go through it step by step. The ideas we would cover would be too specific to that task. So what we're going to do in segments 4 and 5 is to take several aspects of a maintenance task, aspects that are common to just about all maintenance jobs, and develop some rules for good maintenance practices. Now we'll cover disassembly and assembly, what to look for every time you work on any machine, how to take care of spare parts and when to replace or reuse them, cleanliness during the maintenance task, and properly finishing the job. Now, remember that you want to do as much of your maintenance as is practical in the shop because the lighting and ventilation are better, tools are more easily available, and the machine is in a more convenient position for maintenance. Now, you can see our mechanic is set up for a job. He's got his tools, parts, trays for cleaning and holding pieces, and his gloves and glasses. You'll also notice that he's cleaning off the machine prior to starting any maintenance. Now that the machine is clean, let's start with disassembly. There are a number of do's and don'ts common to the tearing down of most machines. First, things must be done in an orderly fashion and by the procedure. If you follow the procedure step by step, you'll be removing parts in the correct order and you're less likely to make mistakes. Try to place the parts you remove on a clean surface, such as a workbench or in a cleaning tray. Place them in the same order as you remove them. Be especially careful when removing small parts, such as set screws, gear keys, and alignment pins. Now, one small part that always seems to disappear is a drain plug that you remove to drain the oil from the machine. Place small pieces like these in a tray or on an uncluttered area of the workbench. It's not a good idea to wrap small pieces in rags. Too often the rag is thrown out with the piece still in it. The idea is to keep track of the parts you remove and to do the job in an orderly fashion. Now, another thing to remember is to be careful when bolting or unbolting pieces from a machine. When working with pieces bolted together, loosen or tighten the bolts by equal amounts in a crisscross pattern. This is so the pieces move together or apart evenly and no one bolt is carrying all the weight. In this side view, you can see that any extra stress from tightening down on one side and not the other can damage the pieces themselves or the bolts that align and hold the pieces. Now, this idea holds true when you're using jacking bolts to separate parts. Turning the bolts equally avoids damaging machined edges that might grind together if the bolts were loosened or tightened unequally. Balancing the load like this applies to any situation in which you're pulling a shaft component off of a shaft. For example, this bearing puller distributes the pressure evenly around the bearing as it pulls the bearing off. Now, there are other types of parts that require careful handling because of their susceptibility to damage. On a mechanical seal, for instance, you want to avoid touching the carbon contact face. Even the grease from your finger can damage the face. Now, another sensitive area is any finely finished surface, such as the lands on a timing gear or a pump shaft. If bumped against a hard or abrasive surface, any nick or scratch can result in the part having to be refinished or even replaced. All right. Well, we've discussed being careful and methodical when taking a machine apart. Now, one more point before we get into reassembly. Witness marks. Using witness marks involves marking two adjacent pieces to indicate how they are set in relation to each other. And perhaps the most common method of doing this is with a small punch or a nail. Now, when you do use a punch to mark a piece, it's a good idea to spray some primer on it to prevent rust. Oh, and don't use a scratch mark. When it comes time for reassembly, you may find there are other scratches on the surface that look a lot like yours. The proper use of witness marks can save you a lot of time and effort. Now, while most of the suggestions that we've discussed so far were related to disassembly, almost all of them also apply when you're reassembling a machine. You still want to be careful, orderly, and methodical. But there are a couple of other ideas that really apply only to reassembly. Inspecting spare parts, for instance. Look over any parts you've obtained very carefully. You don't want to put a damaged or a faulty part in your machine. And check any parts that you're putting back on. Make sure they're the correct parts. You'll be surprised how often you'll find more things wrong than you originally expected if you're careful about checking parts when putting the machine back together. Now, one very important part of reassembly is ensuring you have the correct clearances. Now, clearances are the spaces between parts of a component. Incorrect clearances can seriously affect a machine's performance. And don't eyeball a clearance. The human eye cannot normally detect differences of a few thousandths of an inch. Use a micrometer to make sure you have the clearances that the manufacturer's manual calls for. All right. Now, those are a few key ideas and problems to be aware of when tearing down or reassembling a machine. So before continuing with the other aspects directly involved in the maintenance itself, you stop the tape now and review the segment 4 here with your instructor. In segment 4, we discussed assembly and disassembly. Now let's talk about maintenance inspections, spare parts, cleanliness, and proper maintenance completion. You know, sometimes a man will start a job with exactly what he's going to do firmly fixed in his mind, and he doesn't pay any attention to anything but what he knows the problem is. Now, if you do this, you could miss other problems that might cause more damage in the future. So take advantage of any maintenance job to look for other possible problem areas. See, a vital part of any maintenance job must be a continuous inspection of the condition of the machine as the maintenance progresses. Now, before opening the machine, look for evidence of leakage, primarily around the shaft or the coupling. Too much leakage might indicate a packing or seal problem. As you enter the machine, look for any signs of damage. Sometimes small signs can indicate the beginning of a serious problem. Look for worn spots, cracks, worn rotor lands, or broken gear teeth. Now, if you find problems like these, write them down and plan to do something about them. You know, 99% of the time, it's cheaper and easier to fix any additional problems you find right then and there while you're working on the machine. Some problems can be corrected easily. Cleaning off rust and repainting, for example. Some problems may require new parts, and the sooner you find this out during the job, the better the chances are that you can get a replacement part and install it without additional downtime. Replacing a part in a machine is not simply a matter of obtaining the part and installing it. There are some important things to check before installation. First, double check the part number. Now, some parts will have part numbers with 20 or more numbers and letters in them. Now, if any number is different from the number in the manufacturer's manual, you got the wrong part. There's no being close with part numbers. And the part number may be the only way to tell that you have a different part. Parts that appear interchangeable usually aren't. Besides checking the part number, check any clearances on the part that the manufacturer's manual calls for. You may have the right part, but it may have been damaged during shipment or storage, and sometimes even slight or unnoticeable damage can change clearances and cause the part to fail soon after installation. Now, another important consideration anytime you're installing a part is whether the part should be replaced or reused. Of course, if a part is damaged or obviously not functioning properly, it's going to have to be replaced. But sometimes there is a question, and often the deciding factor is the cost of the new part balanced against the value of replacing it. Now, some parts, gaskets for instance, should almost always be replaced. Gaskets are fairly inexpensive, they're easy to replace, and normally it's just not worth reusing a gasket that might have been torn or scratched during the maintenance task. Try to be as careful as possible when removing a gasket. The old gasket can often serve as a pattern or a template to cut a new one. If you have to remove some packing, it's almost as easy to replace it with new packing as it is to reuse the old packing. This will depend on the availability and cost of the packing. Now, mechanical seals are one area where you can't compromise. If one of the faces on a mechanical seal needs replacing, both faces must be replaced. The two faces wear together during operation, and a new face is not going to seat properly against the old one. All right, one more consideration when you're replacing parts. Keep the new part clean. Dirt introduced during maintenance work is one of the major causes of machine damage. Now, we discussed cleanliness of the work area in an earlier segment of this tape, but cleanliness during the maintenance is equally important. So you want to keep foreign objects or matter out of the machine. Now, foreign objects or matter are anything that's not supposed to be in the machine. Dust, scrapings, lint, bits of tape, dirty grease or oil, even small tools or parts. Now, any of these things can cause damage to a machine with moving parts or electrical wiring. So, how do you go about avoiding these problems? Well, much of it is just common sense. To start with, you want to clean your work area, and we've already discussed that. Now, along with keeping a neat, clean work area, you want to use neat, clean work habits. Now, by this I mean wipe off excess grease or oil. It collects dust. Clean out scrapings, dirt, or the dust from crocus cloth or sandpaper. They'll scrape, abrase, cause binding, and promote electrical shorts and grounds. You also want to protect especially delicate parts until you use them. Bearings, for example, should be kept covered by a lint-free rag. shafts or screws should be supported on blocks, away from any surface that might mar, scratch, or rub them. Now, remember that tool and parts checklist you used to ensure you had everything you needed before you started the job? Well, use it again to ensure that you still have all the tools you started with before you close up that machine. The tool that's left inside can cause a scored shaft or an electrical fire. And speaking of tools, if you have to work in an awkward position, or if you're working in an area where a dropped tool could go a long way or it'd be difficult to retrieve, tie the tool to your body or to the casing of the machine. All right? Now, cleaning up the area after you finish the job is part of proper completion of the task. Cleanup should be habitual, should be an automatic thing. There are a couple of other steps that should also be made an habitual part of completing a maintenance task. After you've cleaned the area, the maintenance paperwork has to be completed. Now, this includes notifying your supervisors that you finished the job. Certain people, such as a ship supervisor or a maintenance supervisor, will have to sign the paperwork. And this indicates two things. One, the job is completed and accepted. And two, the danger tags can be cleared by the operator and the machine put back into operation. Now, whatever way your plant does these things, it's all part of properly completing the job. The last step in the completion of a maintenance task is making the entries in the machinery history records. Now, this is extremely important, and it's often overlooked. What you put in the machinery history record will save somebody time and money if the same problem comes up again. Now, when you make your entry, include what you did, when you did it, why it had to be done for repair or routine maintenance, and any special tools, materials, or hard-to-get parts that you need, and any problems that you ran into during the job. Now, this could all be a real help to the next guy who has to do the job. If he knows the problems ahead of time, your experience becomes part of his advanced planning for the job. Now, perhaps the most important item of information you want to include is the cause of the problem. Now, this information can help prevent reoccurrences of the problem. Remember, now, the job isn't over until the paperwork and the machinery history records are completed. Okay, we've inspected for signs of trouble and double-checked the new parts. We've also discussed the importance of cleanliness during the job, and we've gone over a couple of necessary steps in properly completing a maintenance task. So let's stop the tape now so you can discuss these ideas with your instructor and review segment 5 in your text. Throughout this tape, we've used as examples various instances in which maintenance was performed on a piece of equipment. Now, there are basically two types of maintenance: repair maintenance based on equipment breakdown or malfunction, and preventive maintenance performed to prevent equipment breakdown. A preventive maintenance system, or PMS, can save your plant money and man hours. Now, basically, a preventive maintenance system ensures that periodic maintenance is performed on a machine to prevent the more costly maintenance required to repair a component that's failed. If you didn't regularly check your automobile's oil reservoir, sooner or later you'd blow up the engine. Well, like your car, lack of preventive maintenance on a machine can hurt you three ways. It costs money to repair, takes man hours to fix it, and it could be very dangerous. Now, just as preventive maintenance on your automobile can be as simple as a dab of paint on a rust spot or as complex as a complete engine overhaul, the level and complexity of a plant's preventive maintenance can be as simple as greasing a bearing and as complex as an overhaul of a major piece of equipment. Now, preventive maintenance is scheduled, periodic maintenance. Now, this sort of system has several advantages that a simple repair it as it breaks system doesn't have. preventive maintenance system ensures that maintenance that should be performed on a regular basis is performed and recorded. A preventive maintenance system provides a method of collecting, organizing, and reviewing maintenance procedures. And a preventive maintenance system is based on the information recorded in machinery history, not on the occurrence of a breakdown. All right, so let's take these ideas and explore just what a preventive maintenance system can mean to you. We said that a preventive maintenance system is scheduled and periodic. Now what this means is that the system lists on cards or on a chart just when a maintenance task should be performed on a machine. Now these can be tasks required to keep a machine running, such as checking oil levels or cleaning a strainer. They can also be tasks performed purely to anticipate problems. Vibration analysis tests are an example of this type of maintenance. Preventive maintenance can also vary in how often it's performed. Battery checks may be done daily, while overhauls on a turbine may be done only every 10 or 20 years. So the objective is to perform the maintenance before the repair is needed. A preventive maintenance file lists all of the maintenance tasks that are required on a machine and requires proof that the maintenance has been done. Now, the fact that the system requires this proof is important. Somebody has to sign for performing the job, and that means that somebody is assigned the responsibility for making sure the job is accomplished. Assigning responsibility for a task is the biggest step towards getting it done. Now, another advantage of preventive maintenance is that such a system provides a method for accounting for maintenance procedures. We discussed in an earlier segment of this tape that there were probably two places that you could go to for a procedure: the manufacturer's manuals kept in your shop or the maintenance office, and the master set of manuals kept put away. The preventive maintenance system provides a third place to go for maintenance procedures, but one with a couple of advantages. Well, for instance, while the manufacturer's manual may contain only major procedures, the preventive maintenance system will cover almost every procedure you may need to work on a machine. Also, the preventive maintenance system provides cards or a couple of pages that cover the procedure you need. Now, this is more convenient than carrying around a large, awkward manufacturer's manual. The preventive maintenance system also includes, with the procedure, a lot of useful information that's specific to your plant and will not be in the manufacturer's manual. Well, for instance, the preventive maintenance procedure for a specific task might include how to danger tag the machine out of commission, any special safety precautions required because of the machine's location in your plant, any special rigging requirements caused by the machine's location, how the maintenance on this machine will affect other systems in the plant or the plant as a whole, and how long the job will take. Now, this information is vital to your maintenance supervisor when he makes out his maintenance schedule. All this information can help streamline your plant's maintenance load. Another advantage of a preventive maintenance system is that it is based on plant experience. Instead of waiting for a machine to break down, you use your machinery history records, personal experience, and the manufacturer's input to determine how often a maintenance task should be done. Now, this is extremely important, and it is the heart of a preventive maintenance system. Every manufacturer's manual will list a suggested frequency for a certain maintenance task, but no two machines are alike in construction or in use. For example, you got two identical pumps, but they may perform differently. This is due to two factors. First, there are going to be slight differences in shape, size, and clearances. This is because the manufacturer works with tolerances on his production line. Now, these differences may be undetectable at first, but over 5, 10, 20 years, they'll be magnified. And second, no two machines are going to wind up in exactly the same environment. You may have a pump operating inside a plant, and you may have the same model pump operating outside or on a production line. These differences result in different performance levels and different rates of wear and tear. Now, what this means is that while the inside pump may need a particular maintenance item performed on it once every year, the outside pump may need the same maintenance every month. It's machinery history that provides the information that is specific to your plant. This is why the preventive maintenance system is based on plant experience and why the machinery history records are so important. See, machinery history constantly updates the preventive maintenance system. If machinery history indicates that a mechanical seal on a certain pump is failing more frequently, then the preventive maintenance system will increase the frequency of maintenance on that pump. Accurate machinery history and an effective preventive maintenance system are the best methods available for ensuring efficient maintenance results. Over the last hour, we've discussed a number of topics. We looked at the paperwork necessary to perform a maintenance task. We discussed procedures and the vital need to use them whenever you do a maintenance task. We reviewed the tag-out procedure, safety, and what both mean to you as a maintenance worker. We also looked at areas to consider when planning your task in advance, including troubleshooting, preparing the work area, and obtaining all your tools, materials, and parts ahead of time. We discussed good maintenance practices during assembly and disassembly, and we explained what preventive maintenance is and how it can help you. Now, the ideas in this tape are all basic to the maintenance field. Now, your plant may do things a little differently from other plants, but we've covered general rules and guidelines that should be applicable anywhere and should help you perform better and safer maintenance.